Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and this week we have the following articles. The first article is about Ledger, the crypto wallet, and it's in this article here. Cryptocurrency hardware wallet provider Ledger has launched its latest Ledger Recover service, which enables users to recover their seed phrases used to access their crypto assets with a passport or national identity card. And this requires a firmware update, and this grants the company access to the seed phrase, and that should ring an alarm bell. This service requires approval and a monthly fee of $9.99, which is fine. The seed phrase are split into 3 encrypted fragments stored by Ledger, CoinCover, and a third provider using a hardware security module and HSM. And Ledger, they emphasize the high level of security. However, there are critical voices, especially the critical voices concerned potential risks given the Ledger's past data breach in 2020, and some suggest that the service might expose user to ID theft, which could then be exploited to access the funds. However, Ledger, they insist on the robustness of the process, which includes liveness detection and for confirming the identity. There's more to it. Also, Cointelegraph has an article about it. There were some tweets going around. So this, for example, is from the Ledger support. It says, technically speaking, it is and always has been possible to write firmware that facilitates key extraction. You have always trusted Ledger not to deploy such firmware whenever you knew it or not. This tweet was later deleted, and then the CTO responded with a tweet in a bit more defensive way, saying using a ledger does require a minimal amount of trust, which is actually true for every wallet. So this applies to Trezor, this applies to Bitbox, but the Ledger has now a bad reputation, and other vendors are actually responding to it. For example, here Shift Crypto, they have here a blog article moving from your Ledger Nano S or Nano X to the Bitbox 2 is easy. So if you're not happy with what Ledger is doing, so you can choose your own hardware wallet provider. And my take on this is that they attempt to monetize this service, and the problem is with the crypto community, they prefer, or many of them prefer, maintaining full control over their keys. And this has been a fundamental principle since the inception of Bitcoin in 2009, and some members of this community are really picky on that one. So there is backlash to be expected. And introducing a firmware update that could transfer the seed phrase needs for sure better communication for such a delicate topic. I prefer also to have control over my keys, knowing that they will never leave my hardware wallet. On the other hand, losing keys tend to be more common than hacking incidents. So therefore, this service is, if the service is an optional addition and you can choose to participate or not to participate, then if you don't like it, just try to avoid it. Ledger, they have tried to communicate better. They updated their tweets. However, there has been a huge backlash, which means that some of the trust is gone. However, if you want to switch to other hardware wallets, there are other competitors. There is Trezor, there is Bitbox, there is more than that. So there's always a choice, and you also can you can choose not to participate in this Ledger backup. Let's see how this continues, if they can regain the trust from the users, but I see their point. People lose their keys. I have seen cases where they just forgot or they lost their keys, and hacking incidents also happen. But in my personal opinion, it happens less frequently. The next article is a bit older, but I missed that one. And one student group is actually using ScyllaDB. And I was taking a deeper look into that, and I stumbled upon this interesting article from Discord. It's about how Discord stores trillions of messages. And in this blog post, the author explains how Discord has evolved its database management system to handle trillions of messages. Initially, they used MongoDB, then they shifted to Cassandra to scale out, and that happened in 2017. That resulted in better scalability. However, the Cassandra system began to have some serious performance issues, especially with hot partitions, which affected latency across the entire database cluster, leading to end user impacts. So they needed to change, and the team at Discord, they choose to move from Cassandra to ScyllaDB, which is compatible with Cassandra, and it's written in C++. And due to its promise of improved performance, fast repairs, and workload isolation, and no need for garbage collection, so Cassandra is based on Java, it needs garbage collection. Discord wanted to gain experience with ScyllaDB before migrating their primary database, Cassandra Messages, which held trillions of messages in nearly 200 nodes. And to deal with the hot partitions issue, Discord developed a kind of a data service. They used Rust for that, so not C++, but Rust. And they executed a large-scale migration of data from Cassandra to ScyllaDB, rewriting their data migrator in Rust to achieve a fast transition. And they managed to migrate these trillions of messages with no downtime. So this is very impressive, a huge system, no downtime. So that's quite an achievement. Discord ScyllaDB systems proved to be quite efficient, and from almost 200 Cassandra nodes, so they mentioned that they had 177 Cassandra nodes, they required then 72 ScyllaDB nodes because it was more efficient. It was not Java, it's C++, so it's more efficient. And the switch also significantly improved latency, performance, and also demonstrated higher resilience, especially during high traffic events. So they had this World Cup final where they saw lots of messages, and those nodes, those ScyllaDB nodes, could handle them quite well. So migration of that size with no downtime, I think that's quite impressive. The next article is about scaling up. It's this article here. So this post compares scale out strategy, so using many machines, against scale up strategy, just making the machine faster, more CPU, more RAM. And the argument in this article begins with the historical context of Google, where they pioneered the scale out strategy due to financial and scalability constraints 20 years ago. But they state now that modern hardware has increased in power by orders of magnitude since then. And they argue that many of the reasons for scaling out back then, 20 years ago, it's not valid anymore, or the machines just become so fast that they can handle the load. So for scalability, while scaling out initially addressed the big data problem, the data sizes and workloads are generally smaller than people perceive. So just if you think you have big data, just try to run it on the machine, and then you see if you have big data or not. And modern single node systems have grown significantly, being able to handle a huge workload. Also, with respect to cost, there's an argument that the cloud and those big machines are expensive. And traditionally, larger machines were disproportionately more expensive, but in the cloud era, cost per unit of compute doesn't change significantly with instance sizing, making scaling much more economically. And there was also a reliability argument that the scale out leads to a more reliable system than scale up. And while scale out architectures were designed for great reliability, cloud availability is often influenced by external factors. Scale up systems can achieve similar level of reliability with improvements in infrastructure and cloud offerings like the separation of storage and compute. The author also discusses some of the benefits of scale-up architectures such as simplicity and performance, which I like very much. Scale-up systems are less complex to build, maintain, and troubleshoot compared to distributed systems. That is for sure true, especially the troubleshooting of a distributed systems. This is quite painful or can be painful. They also perform faster because they avoid network latency, which of course you have in a distributed systems. So my take on this is simplicity first. But if your application consists of self-contained services, then it doesn't matter that much where the service runs. However, if your service runs at capacity and it's not easy to split the service into multiple self-contained parts, then first scale up. It's much simpler. The last article is about how to improve SSR static site rendering. It's not pure SSR, but it's where the site is not rendered entirely on the server, so there needs to be some client calls as well. So it's something like SP8 single page application, but parts of the site is rendered on the server. And it's the following article here. It discusses how Airbnb improved page performance using HTTP streaming. The technique involves breaking the response into chunks, which are sent as soon as they are ready. This improves performance as compared to the traditional buffered strategy, which involves generating the entire response and sending it over the network. So that means instead of having this, sending the site, once the site is there, do the client data fetch. So what they did basically is here, when the static is being generated here with an early flush, they also send the instructions on how the client can fetch the data. So Airbnb's implementation of HTTP streaming involves the technique called early flush, as I just mentioned, which breaks the standard response into two parts. The first part includes the tags for the font, CSS, and the JavaScript that is sent quickly. And the second part contains the rest of the page. So in the first part of the data, there you have the instruction for the client call, which is then sent to the server, flushed, so it really actually gets transferred and not buffered. The client can execute it, and you will see the page load much faster actually. This helps reduce network waterfalls, so they made also here this comparison here, and so that they actually could improve that. Airbnb's app, they use Express on Node.js, they're using React to render the web pages, and to even improve the page load time, they introduce now also a third chunk called deferred data, and this chunk comes after all the visible content and does not block the rendering, executes network requests on the server, and streams the response into the deferred data chunk. So everything that's not essential will come afterwards. And the implementation of HTTP streaming resulted in a significant improvement in web performance, and they reported that the early flush reduced the first contentful paint by around 100 milliseconds on every page tested, including the home page. So what is this first contentful paint? Well, this is a user-centric metric for measuring the perceived performance of a web page. It provides the timing information when the first bit of content from the DOM is rendered on the screen. So basically everything that's in the body when this arrives and starts to paint. So this is actually the first contentful paint when you start to see the web page. So as a side note, my bachelor student that work on flat fee stack, they're using SSG, static site generation. However, I think with an early API call in the HTML header, maybe with a modified caddy, or no, for sure you have to modify the caddy, that could implement an early flush, could also bring some performance improvements, but those are just ideas on how to improve the performance.